All right, let's get into it. Everyone's talking about bigger and bigger AI models. But what if the real breakthrough isn't about making one AI smarter, but about making a whole team of them work together? Today, we're going to break down how these multi-agent systems are engineered and see how they're completely changing the game for complex research. Look, a single large language model, it's powerful stuff, no doubt. We've all seen what they can do, but that's just the starting line. The real game changer, the thing that unlocks the next level of performance, is when you get them working as part of a coordinated, intelligent team. That's when things get really interesting. So to really get why this team approach is such a big deal, we've got to start with a problem. Why does a single AI agent, even a brilliant one, eventually hit a wall when you throw a really hard problem at it? Think about it this way. A single agent works sequentially. It's like it's trying to solve a huge mystery by looking at one clue at a time, in order. But complex research isn't like that, right? It's messy. You need to explore a dozen different leads at once. A single agent just can't do that. Its working memory, its context window, is limited. It gets stuck, going down one narrow, inefficient path, and it can totally miss the bigger picture. Okay, so what's the fix? Well, it's a fundamental shift in thinking. We need to stop seeing AI as this one singular Oracle-like tool and start thinking of it like a manager building out a specialized research team. And this is exactly the kind of architecture that teams at places like Anthropic have been pioneering. And, this idea isn't pulled out of thin air. It's actually a classic, battle-tested concept from computer science called the orchestrator-worker pattern. It's super intuitive. You've got a manager, the orchestrator, who makes the plan, and then you've got the specialists, the workers, who actually get the job done. It works for building software, it works for building houses, and it turns out it works incredibly well for building AI systems. So let's break down the roster of this AI team. First up, you have the orchestrator. This is your manager, your lead researcher. It takes your goal, breaks it down into a smart plan, and hands out assignments. Then you've got your sub-agents. These are the specialists, the workers on the ground, each tackling their own piece of the puzzle at the same time. And this part is absolutely critical. You have a validation agent. Think of this as your dedicated fact checker. Its only job is to go through everything, verify the sources, and make sure the final report is solid before it ever gets to you. Okay, we've met the team. Now, how do they actually play the game? Let's walk through the entire workflow, from the moment you type in your query to getting that final polished report. So you ask it something complex, like find all the emerging AI startups in healthcare. The lead agent doesn't just start searching. Nope. First, it creates a strategy. It might say, okay, I need 3 specialists for this. It spins up one sub-agent to dig into funding data, another to research clinical applications, and a third to investigate the regulatory landscape. See, they're all working in parallel. Once they're done, they report their findings back to the lead agent, who synthesizes all this information into a single report. Then, for the final, crucial step, the citation agent verifies all the claims. Only then do you get the output. So that's the how. It sounds logical, right? But the why is where it gets really powerful. This isn't just a neater way to organize things. This team-based system delivers a massive, and I mean massive, performance boost. The first and most obvious win is just raw speed, parallel execution. A single agent is stuck going step by step. It's a bottleneck by design. This multi-agent system is the opposite. It's like going from one person trying to build a car to an entire assembly line. You're exploring so many different paths at once that you find the answers way, way faster. Next up is specialization. This is huge. You wouldn't have one person on your team. It'd be the CEO, the coder, the marketer, and the accountant, right? You hire specialists. It's the same idea here. You can fine-tune each sub-agent with specific instructions and tools for its narrow job. One agent can be an expert in financial analysis, another in scientific literature. That level of focus means the quality of work for each subtask goes way up. And this last one, context scaling, this is the real technical breakthrough. See, every AI model has a limited context window, a limited short-term memory. By splitting the work, you're not trying to cram a massive, complex problem into one agent's tiny memory. Instead, each sub-agent has its own memory for its own task. You're basically adding up all their memories, letting the system process an amount of information that would have been literally impossible for a single agent to handle. And look, this isn't just theory. The proof is in the numbers. When Anthropic ran internal tests, their multi-agent system beat a top-of-the-line single agent by, get this, over 90%. That's not just a little better. That's a completely different class of performance. And you can see why this happens in research on parallel tool use. Just look at the data here. As you let the models use more tools in parallel, going from 1 to 3, the number of turns or steps it takes to get the job done drops for every model. More workers means fewer steps. It's that simple. It's just a more efficient way to work. Okay, so this system is faster, smarter, and more scalable. Sounds perfect, right? Well, as any engineer will tell you, there are always trade-offs. This power comes at a price, and it's super important to understand what you're giving up. And the biggest price you pay is, well, the price. Tokens. A multi-agent system is thirsty for tokens. Anthropic's data shows it can use about 15 times more tokens than a regular chat. That's a huge deal. It means you don't just throw this at every problem. This is a high-performance engine you bring out for the high-value, complex jobs where the cost is justified. So let's put it side by side. Single agent, slower, cheaper, and way easier to debug because it's predictable. Multi-agent, blazing fast, scalable, but it's expensive and a nightmare to debug. And that's a key point for anyone who's ever had to maintain a production system. The agents can find different, equally valid ways to get to an answer. That's called non-determinism, and it makes finding and fixing bugs incredibly tricky. So when do you pull this powerful, expensive tool out of the toolbox? It's perfect for those big, messy research questions that you can slice up into parallel tracks. Think market analysis, scientific discovery, or legal precedent research. But for a simple, direct question, it's total overkill. And for tasks like coding, where every single step depends on the one before it, it's actually the wrong tool for the job. You need that shared sequential context. Okay, let's pull back for a second, because this isn't just about a cool new architecture. This points to a much, much bigger shift in where AI is heading. If there's one thing you'd take away from this, it should be this. We are moving from an era of AI as a tool to an era of AI as a system. The real power is no longer just in the raw intelligence of a single model. It's in the emergent intelligence of a well-orchestrated team. And this is what the future looks like. We're talking about autonomous agent teams that you assign to high-level business goals, not just simple prompts. We're talking about systems that can build and change their own workflows on the fly to solve problems we haven't even thought of. And this is going to create a whole new category of software. AI orchestration platforms, built just to manage these complex AI teams. Our job is changing from being the one doing the work to being the one directing the work. So I'll leave you with this question. As these AI teams get better and more autonomous, would you trust one to do your research, to handle a critical part of your job? It's a question we're all going to have to answer sooner than we think, and it gets to the heart of what it means to work and create in the age of AI.